each of the files here is a number of tourists, x thousands, so that is tourists, and it's in thousands. And the average weekly sales, so that's sales, and that is also in £1,000, is y. Okay. Results for things. Calculate product moment correlation coefficient R between x and y. So I need my formula sheet. So I open my formula sheet. It's page 9 as it is at the moment. I will just put it in here now. And so we want R. R is given here. It's not summarised the data. This is a bit of a pain. But I can't use this one x. I don't know x bar and x minus x bar. That's going to be horrible. So I'm not going to do this way. And although this bit's exactly the same as I've got it here, I prefer using the small bits here. So I need to work out, or I need to find out. I don't want to do the middle ones because I don't know that data is not summarized that way. So I'm going to record and work out these things. So first off here, I'm going to put the sum, add all those x's up. It gives me 1,366. Add all the y's up, 17.6. And what else do I need? I need the sum of the x squareds. So that'll be 2v squared plus that'll be 270 squared, and that add all those up gives me 374,460. The y squareds, again, that's going to be 4.2 squared, etc. That's going to give me 62.82. And finally, x, y's. Well, the first one will be 250 times by 4.2. The next one will be 270 times by 3.7. And if I add all those up, I get 4,784.8. And now I can work out what these things are. SXX is sum of x squared, so that's 374,460 minus the sum of x, which is 1366 squared over n. How many have I got? I got 1, 2, 3, 4, 5 of these. And so that will give me 1268.8. I can do exactly the same things for the other bits, and this will give me, I'll put the working down as well, but I'm actually going to pause it to do it now. So having worked out those, I can now work out what my R is. It is sum of the xy, so that's minus 23.52 divided by the square root of the other two times together, which is 1268.8 times by 0.868. So R will equal minus 0.708730. So R equals minus 0.709 to 3 significant figures. It's quite an estimate the average weekly sales of Slackton stores in a year when the number of tourists is 280,000. I've got to use an appropriate regression line, and here it's being based on tourists, the number of tourists. And so if it's going to be based on number of tourists, and tourists is the x, so it's based on x, so therefore I want y on x, or y based on x. So I've got from a formula sheet, I've got, that's my thing, y on x is this way round, a is this, and I've got to work out what b is first. So I get that b, this is part 2, I want y on x, and I've got b equals sxy over sxx. That's on the formula sheet, so minus 23.52 over 1268.8, and that is minus 0.0185735,372 actually. So that's worked out what my B is, and now I can work out what A is. A is y bar minus B. So we'll do y bar first, which is the sum of the y's, which is 17.6, over how many there are, 5, and take away B, which is minus 0.01857, then again 372, times by average of x, which total of x is 1366 over 5. And so that gives me a equals 8.584363. And now I've got a, I've got b, and so I've got my formula. That's what I want. Y equals a plus b x. So y equals 8.58 plus, it's not plus in this case because b is minus, so minus 0.0185x, and that's to three significant figures. Don't really need three significant figures because the y is only given to two significant figures. I've now got to find it where number of tourists is 280,000, but watch out because the tourists are here is in thousands, so I need to sub in that x equals 280, and I will get y equals 3.39400, but that is in £1,000, so therefore weekly sales equals 3,394 because it's 3.3 times the 1,000. And part 3, longer period, the value of R is minus 0.8, shows that having more tourists causes sales at Saxon stores to decrease. Well, it might do, but it can't say it because the important thing is correlation does not imply causation. It might do, but we don't know that it's actually caused by it. So that's question 1 done.